we began the class. This is the 1704-19 class, I believe. Asking how many tiles there were on the floor. The floor is overlaid with tiles of uniform size. And I turned the class loose, allowed people to wander around the room. I don't think anybody actually counted the tiles. I think everybody counted how many it was across the room and how many along the length of the room, and multiplied the two results. Now, there's some ambiguity of what I mean by the floor. We have, for example, cabinets around much of the room. So some people would have looked at only the part of the floor that didn't have the cabinets, but there are parts that are not covered by the cabinets, and different people made different types of estimates, okay? So our estimates turned out to be 525, 572, 676. These aren't quite in order. These are the two lowest. If you switch these two, then they're in order from the lowest to the highest, but this is just the order in which I wrote them down as I went around the room. Okay, so we have some range of estimates here. So we digressed for a minute because the main point here isn't means and standard deviations and box plots, but some people still have a test to take today, and thought we'd maybe just do a little bit with a box plot. There's no reason to expect that these results would be normally distributed. The result itself, if we really defined what we mean by the entire floor of the room, would be pretty unambiguous, and I think everybody would get about the same result. So we don't really expect this to be normally distributed. There are no real random uncertainties in the calculation. But if we just take these and look at what a box plot looks like, our median, well, here are our two middle numbers there. If we go lowest to highest, these things would be in reverse order, but there's still the two numbers in the middle, and the average of those two numbers is 663, so that would be our median. Our first quartile would consist of the three numbers below the median. That would be this one and these two. There are three numbers, so the one in the middle, which would be this one, would be our first quartile. And then the three highest numbers, this one, and this one. This one is the one in the middle, that's our third quartile. We can draw then our box and say, okay, well, let's see, between the first quartile and the third quartile, the difference appears to be 164. If I subtract, and if I did my arithmetic correctly, the difference would be 164. Now, between the first quartile and the median, which is 663, the difference is 91. So from here to here, from the first quartile to the median would be 91, and from the median to the third quartile is 73. 91 and 73 does add up to 164, so maybe I got that arithmetic right. So we see that this part of the box is wider than this part of the box. The median is closer to the third quartile than it is to the first quartile. Then we have the low and the high, and the low, which is the 525, is 47 below the first quartile, which is 572. And the highest result, this end of the range, is the 780, which is 44 above the third quartile. So that these tails here would actually be quite a bit shorter than either of these sections, and actually I probably drew them a little bit too long, so it's fairly short tails. Okay, so we have that, just a box plot, and actually we might think in terms of box plots of some of the other calculations that we get. Now, we ask the question, if we make blocks that cover one of the tiles, that have a footprint that's identical to that of one of the tiles, nice rectangular blocks. And the height is the height of one of the concrete blocks along the wall. Okay, we have concrete blocks going up the wall. We can count how many there are from the floor to the ceiling. If we have blocks with those dimensions, how many would fit into the room? Okay. Well, people got these results, and one person, I think, anticipated another question, did something actually pretty sophisticated, but got a result that wasn't in this range. Okay, I think the result was 4,000, and I understand what that person did. It was actually very good thinking, but it didn't exactly answer this question, so I left that one out for the moment. That person came back into the fold here because what he or she had done was actually very compatible with the next question. Okay, so if we did these, well, you know, I just asked the side question, would the box plot be pretty similar? You can do a box plot and see what you think. Okay. Now, and all people did with this is they said, well, okay, there are whatever number, you know, one of these numbers, whatever number person got of tiles on the floor, you'd have to put a block on the floor for each tile just to build it up to the height of one of the concrete blocks. And then you'd have to do that for the second, the third, the fourth. So you would have this number times the number of concrete blocks up the wall, and that would be the number of blocks that you would need to fill the room. Okay? And I didn't actually say, I mean, I kind of said it. How many blocks covering one tile with a base of the height of the concrete block? I should put this in to fill the room. People understood that. That's the problem that they did, but I didn't really write it down as well as I might have. Okay. Okay, well, the next question is going to be, and I'm going to stop the video here before we get to this, but each tile, I tell you, is a 1 foot square. It's 1 foot by 1 foot. How many 1 inch square tiles would it take to cover the floor? Answer that question if you haven't already. And there are actually two ways to answer it. Maybe you can think of both of them.